Alright guys, this last video which we're going to do for logarithms, we're actually moving to the next section 3.4, and we're going to look at three properties of logarithms, and we're going to use them to either expand or condense logarithms. And you're going to see these properties we're really going to use for when we solve logarithmic equations, which will be the following day. What I would do right now, just pause the video, and everything that's written in red, just write that down first. Okay, hopefully you have all this down right now. Here's kind of the main thing, and I'm just going to highlight, and then we're going to put numbers into it and apply these properties. If you have a single logarithm and you have two quantities and you multiply them, like that's u times v, you can expand the logarithms. You always want to keep the same base, so I keep that same base of u, and then I just add. So kind of think of it, alright, if you multiply in one logarithm, then you can add those two quantities that are being multiplied to two logarithms. Now likewise kind of makes sense if I divide. If I have u divided by v, now when I expand it, I can subtract. And the main thing to remember, the logarithm that you subtract is whatever quantity is in the bottom. So since that v is in the bottom, that's why this negative is with this log base a of v. Okay, and the last property, if you have a logarithm and the argument has an exponent, here it's n, you could rewrite this by writing the n right down there, and you would have n times the log base a of u. Alright, so make sure you have them down, and let's go to the next page, and the next page looks like we are going to expand each logarithmic expression. Alright, so on this page we're going to expand the logarithms. So let's make this bigger. So if you look at the argument, I have a whole lot of things going on here. 5x cubed y. Now here's the easy thing to remember. Alright, here's a question to ask you. With that 5x cubed y, what are you doing? Are you multiplying or are you dividing? Obviously you're multiplying. Now since there's three quantities, I have 5, the x cubed, and a y, that means I'm going to add three of them. I'm going to have three logarithms that I'm going to add. I'm going to keep this same base of 4. So when I expand this, I'm going to have log base 4 of 5 plus log base 4 of the x cubed, and then plus log base 4 of the y. Now the only other thing that we can do, the exponent, that's the third property that we just went over. Remember, I can take this and move this right there. So when I write out the answer, I have log base 4 of 5 plus, right, I move this 3 down, so I'm going to have 3 times the log base 4 of x plus log base 4 of y. So I expanded that to 3 logarithms. Okay, I want to skip to number 18. Okay, number 18. Well, what kind of stands out with number 18 is that I have division, so I'm going to have to somewhere in here subtract. But if you look, within here, you're multiplying, so you can add those two quantities. So I could put natural log of x plus the natural log, and actually what I see here, I'm going to put this all in once. Since that exponent's 4, I'm going to put a 4 in front of this natural log of y. Right, because I'm doing x times y to the 4th. And then here's the main thing. Since this z to the 5th and t cubed, since that's in the bottom, then I'm going to subtract those two logarithms. And I'm going to put the exponent in front, the 5 and the 3. So I'm going to have minus 5 times the natural log of z, and then minus, the exponent here is 3, so then minus 3 times the natural log of t. Alright, so I expanded that out to 4 natural logarithms. Alright, the last part is we have 19, 20, and 21. This is where we're really going to use this to solve equations. We're going to do the opposite of what we just did. So we're going to start with something that looks like this, and I'm going to condense it to 1 logarithm or 1 natural logarithm. So let's move down to 18. So you can see, using the properties, condense the expression to a single logarithm. Alright. So I'm just going to go backwards here. The first thing I notice, I have this half in front, so I'm just going to put this right here. This is like saying x to the 1/2. The other thing I notice, since this is plus, if I condense, that means that, I'll put this in a different color, this x to the 1/2 and this x plus 1, I'm going to multiply those together. So when I rewrite this as one logarithm, I'm going to have log base 10, I'm going to have that x to the 1/2, and I'm going to multiply it by this, the x plus 1. Oh, and actually the one thing I forgot here, I have this 3 in front, so I'm going to put this 3 right there. So I'm going to multiply it by x plus 1 quantity cubed. You could leave your answer like that, or if you wanted to take this x to the 1/2, that's the same as taking the square root. I would also accept this as the answer, log base 10 of the square root of x times x plus 1 quantity cubed. I would also accept that. Either of those are correct. Let's see here. I'm going to skip down to 21. Okay, 21. Got a couple things going on here. See, we're adding. So I know that we're adding. And then since you're distributing this 1/3, it's almost like you're raising the whole product of the x and x plus 1 to the 1/3. So I'm going to rewrite it as log base 2. Right, since I have this addition, it means I'm going to multiply this x and this x plus 1 for the argument. So I'm going to have x times this x plus 1. Now the only thing I have to take in consideration is this 1/3. Remember, if that's 1/3 times, I could move this up and have the whole thing raised to the 1/3. So that's what I'm going to do. I'm going to put brackets around this entire thing and raise it to the 1/3. And you could leave your answer like that, or the other way of writing it out. If you raise something to the 1/3, it's the same thing as taking the cube root. The other correct answer for this would be log base 2. And then if you took the cube root of x times x plus 1. Either of these are correct. All right, so those are kind of the three basic properties of whether you want to expand logarithms or you want to condense it to one single logarithm.